Welcome back to I Am One, everybody. Today's topic 4.1.1. How can I make predictions? So today you will be able to create a scatter plot and determine its correlation by approximating the line of best fits. So we're moving a little bit away from algebra. We're starting our stats unit. So unit 4 is going to be stats. So we're going to start off by doing scatter plots. Now, if you guys are not familiar with a scatter plot, it's just something that has lots of dots. All right. So that's exactly it. It's just a graph that has a lot of dots, or in this case, a lot of points, right? So let's start off by graphing our scatter plot. So here, when you guys do a scatter plot, you're actually comparing two quantities, all right? So if you notice here, we have two quantities. We have the age, and then we also have the teaspoon, TSP, yeah, teaspoon sugar per cup. So this is pretty much, we're comparing that uh, during age 7, on the average, a person will consume 1.2 teaspoons of sugar per cup, for example, stuff like that. All right. So now let's make our graph. That's the first thing we're going to do, right? So first thing, let's label our axis. The y-axis will be the sugar per cups, and then the x-axis would be the age. So let's put the age at the bottom. And if you guys notice, the age is in years. So let's make sure you say years. And then on the side over here, we're going to put the teaspoon, the amount of sugar, right? The amount of sugar. All right. And that one's in teaspoons, right? Okay. So now our first point is going to be 7 comma 1.2. So we go first again. We start off at 0. We go to the x. And then we go up to 1.2, which would be about right there. So that's going to be our first dot right there. And then 15.1. So let's look at 15.1 is right there. And then 35 0.3. 35 0.3 would be right here. Now, if you guys notice, there's no particular order here, so that's why. Just make sure you're just plotting points here. You're not connecting it. You're just plotting the points. That's very important to remember when you guys are doing scatter plots. So 18 and 0.8. 18 and 0.8 would be about right there. And then 18 and 0.6, we're going to say it's about right here as well, right below. And then the next one is 29 and 0.6. So 29 and 0.6 is right there. And then 44.7. 44.7 would be about right there. And then 53.0 is down here. And then finally 51 and 0.5. So 51 and 0.5. All right. So one of the things we do want to notice here is what we talk about, it's correlation. So correlation, you just pretty much have an idea by looking at the graph, right? If I look at all these points, I tend to see that they're going down as age goes up, right? So we can say that the correlation of this can be negative, right? So if you guys see a graph going down, we're going to say that the correlation is negative, like in this one right here, okay? And we're going to talk about it a little bit more right now. And then if there is no correlation, like if there's dots all over the place, like you guys see them right here in this graph, so we're going to say no correlation. And if the dots were going up, then I would pretty much change it and I would say, okay, the correlation here is positive. All right. So depending on, remember, we're reading the graph always left to right. So if left to right is going, we tend to see that all the points are going up, right? So that's a positive correlation. If all the points are all over the place, right? There's like nothing to see. You can't determine whether it's going up or whether it's going down. Then that's pretty much when you say there is no correlation. And then finally, if you see that all the dots are following a trend, right? That they're all going down as age, or in this case, age goes up, right? Then we can say it has a negative correlation. All right. So now that we have the graph, right? So one thing I do want to point out is that pretty much any any graph, any scatter plot will have some type of correlation, right? Or it'll be positive, it will be negative, or there'll be no correlation. All right. So make sure you guys are always looking for that when you guys are doing the 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 scatter plots. All right. So let's look at the next part. So what is the trend line or line of best fit? All right. So we call it the line of best fit. So it says use a ruler to draw a trend line that overlays the graph with the same number on each side of the line. All right. So with the same number of dots on each side of the line. So we want to pretty much draw a graph right here that not necessarily connects, but it has the same amounts of dots on both sides. So what you guys want to do is just draw a straight line that splits up this amount of dots evenly. All right. We're gonna let's see. It looks like about I would say about right here would be pretty much even to where we would say most of the dots are on one side and then most of the dots are the other side. All right. Yeah, about right there. So we have one, two, three, four, and then here this one's on the line, so that would be one, two, three, four. Yeah, so it's pretty even, right? So that's pretty much how we would just eyeball the line of best fit, right? So this is just an approximation. This is not actually what it is. So let's answer the first question right there. What type of correlation do you see in the graph above? So again, the line is going down, so we can say that in this case, the correlation is negative, right? And then it says, which would you expect to be most likely for a 30-year-old, 38-year-old? 0.2 teaspoons or zero point 0.5 teaspoons or 1.1 teaspoons of sugar. So the nice thing about the line of best fit is that we can pretty much give it a guess, right? It would tell us an approximation of what the 38-year-old would do. So if you guys notice right here on the graph, so 40 is right here. So I would say about there is our value. So we're going to do it right. So it was about zero point 0.5, right? So we're going to say 0.5. So 0.5 teaspoons. It says, what type of correlation would you expect between these two variables? Explain why. Explain why. So now again, remember, you guys are looking for correlation between two variables, right? We're comparing two variables. So in this case, we're comparing the number of minutes taken to deliver a pizza and then why the number of stars given for customer service rating. So what do you guys think would be the correlation here? Would it be positive? So if the number of minutes increases to deliver a pizza, does that mean that the number of stars given in customer service will also increase? Or there is no correlation, right? It doesn't really matter. People don't really care what time the pizza is there. Pretty much that would be no correlation. Or finally, does the number of minutes taken to deliver a pizza as they increase, does that mean that the number of stars given for customer service would decrease? Right. So the case here would be that we have negative correlation, right? The longer you take to deliver a pizza, the longer you take. The less stars you will have, right? Less good reviews, I would say, you would have. You